Here we go. And what we're going to do tonight is a little bit of a review because we've covered a lot of stuff. And I think it helps to say the same thing again, but in different ways to reinforce stuff. So we spent a lot of time on meditation. So we're going to start with a video. Hold on one sec. On meditation. Hold on. Let me just see. How do I get out of this thing?
I think you've overwhelmed it.
I've got all these windows open and now this one works, this one works. Where did everybody go? Oh, here you are. Here. Okay, hold on. I think I have to.
It's a different environment.
Yeah, that seemed to do
We're
it.
hiding.
Here we go. I'm going to go to a share screen and I'm going to go to this. Here we go. Okay, and we're going to start off with a video on meditation.
Now, this
Just
is our
everything is going to start from meditation tonight. Everything. That's really how the whole course was built. If you reflect on this, was by going to meditation, you'll end up discovering the things that we've been talking about here. So keep that in mind as we run through this. Here we go.
We're saying that a lot of these concepts are, part and parcel of the collective unconscious. And so there's different ways of.
I'm a psychologist and a neuroscientist.
It didn't like that.
It looks like you have to.
Oh, here we go.
Scientist by training. When I first began my career, I began with a question. Why is it that some people are more vulnerable to life's slings and arrows and others more resilient? And that question is still central to all the work that we do. And we are particularly interested in how we can nudge people along this continuum to nourish and nurture the qualities that promote human flourishing. In the early part of my career, I focused almost exclusively on the negative side of the equation, on adversity, on the brain circuits that were important for understanding why some people are more vulnerable to stress, why others may be more likely to develop a depression or anxiety. And then something very significant happened in my life. In 1992, I first met His Holiness the Dalai Lama. And this picture of His Holiness was taken in Madison, Wisconsin. And he's visited us several times. And he was the chief inspiration in our turning toward the positive. And in that critical moment in 1992, he challenged me and he said, why can't you use the same tools of modern neuroscience to study kindness and to study compassion in addition to studying anxiety and fear and depression and stress? And I didn't have a very good answer for him on that day other than that it's hard. But when we first began to study kindness, when we first began to study anxiety and depression, that was hard too, and we've made some progress in that area. So the work that we and others have been doing is predicated on a critical insight in modern science, the insight concerning neuroplasticity. Our brains are constantly changing, constantly being shaped by the forces around us. But we have typically very little awareness of what those forces are. Our brains are changing wittingly or unwittingly. Most of the time it's unwittingly. Most of the time we're not aware, and we also have little control over those forces. And the invitation in the work that I'm sharing with you today is that we can actually take more responsibility for our own brains by transforming our minds. But first, let me share with you what some of the consequences of having our brains being shaped unwittingly are. And I'd like to focus on 4 challenges that have been critical in our society today. And these challenges are failures of well-being in very important ways. The first is distractibility. Research indicates that if we take people out and about in the world and we text them, and this has been done in a study that was published a number of years ago, very influential study with several thousand people. We text them and we ask them 3 questions. The first question is, what are you doing right now? And they check off from a list of activities. Second question, where is your mind right now? Is it focused on what you're doing, or is it focused elsewhere? And the third question is, at this very moment, how happy or unhappy are you? Here's what was found. The average American adult spends 47% of her or his waking life not paying attention to what we're doing. Folks, we could do better. And when they were not paying attention to what they're doing, they were significantly less happy. The scientific paper upon which this is based was titled, "A Wandering Mind is an Unhappy Mind." In addition, there is a huge increase in the incidence of attention deficit disorders in children in this country. This is a graph showing a trend over the last decade. There are many reasons for this increase, but some of them have to do with a genuine increase in distractibility. If we're all honest with ourselves, our nation is suffering not simply from a fiscal deficit, but from an attention deficit. We also are suffering from loneliness. Despite the fact that we're all so much more interconnected, 76% of middle-aged Americans report that they have moderate to high levels of loneliness. And this loneliness is not an ephemeral, subjective state. It also impacts our bodies, our physical health. Recent research shows that loneliness is actually a more significant predictor by more than a 2-fold magnitude of early mortality compared to obesity. So this exacts real tolls on our brains and our bodies. And again, research shows we can do better. Negative self-talk and depression, we all have a narrative in our mind that we carry around about who we are. And sometimes we have negative beliefs about ourselves, which can culminate in depression. And this turns out to be a very serious problem. Depression is on the rise. If you look at trends just over the last few years, what you see is a very large increase, particularly among women. Over the last 3 years alone, there's been a 33% increase in diagnoses of major depression in women. And this trend is occurring in teens as well. These are disturbing trends in kids ages 12 through 17, and the gender difference also is very, unfortunately, robust, where the incidence is much greater in females, and this trend is getting worse over time. And again, the evidence suggests that we can actually train our mind and harness the power of neuroplasticity to change these qualities in our mind. Suicide rates are very disturbing. During the Great Depression, there was a huge elevation, and those rates have come back down. And then since the year 2000, there has been, unfortunately, a steep rise in suicide rates. And again, this is not something restricted to adults. Our teens are showing more than doubling over the last 10 years in suicide, so that today in the United States, unfortunately, more than one teenager every single day is taking her or his own life. There also is a pervasive loss of meaning and purpose that people are reporting. And this loss is not simply, again, a subjective quality, but also exacts a toll on our health and other aspects of our well-being. Research shows that a lack of purpose predicts an early death. In a recent study, people who are in their 60s with a low sense of purpose had more than twice the likelihood of dying within 5 years compared to people who reported a high sense of purpose. So again, there are intimate connections between our psychological well-being and our systemic health. Each of these challenges affects the mind and the brain. We're not thriving, but the invitation is that we really could be. So we've developed a framework for understanding a healthy mind. And this framework includes 4 pillars. The first pillar is awareness. And awareness includes the capacity to focus our attention, to resist distraction. It also includes a quality that psychologists and neuroscientists call meta-awareness. Meta-awareness is knowing what our minds are doing. How many of you have ever had the experience of reading a book where you're reading each word on a page, and you read one page, you may read a second page, and after a few minutes, you have absolutely no idea what you've just read? That is an example of a lapse in meta-awareness. But the moment we recognize that we've been lost and come back, that is a moment of meta-awareness. And we have reason to believe that meta-awareness is crucial. Actually, it's necessary, we believe, for real transformation to occur. The second pillar of a healthy mind is connection. Connection refers to those qualities which nurture harmonious interpersonal relationships. Qualities like appreciation, like kindness, like compassion, having a positive outlook. And again, the research shows that it doesn't take much to start activating these latent qualities which can flourish and become stronger. The third pillar of a healthy mind is insight. And insight is about insight into the narrative that we all have about ourselves. At the very extreme end of the continuum, there are people who have a very negative narrative. They have negative self-beliefs, and they hold those beliefs to be a true description of who they are. That is a prescription for depression. And a healthy mind entails changing our relationship to this narrative, not so much changing the narrative itself, but changing our relationship to it so that we can look at the narrative and see it for what it is. What is this narrative? It's a constellation of thoughts. And when we can see it as that, we can foster more room, more breathing room, and this leads to increased well-being. Finally, the last pillar of a healthy mind is purpose. And here we're talking about having a sense that our life is headed in a particular direction. And most importantly, it is about taking more and more of the activities in our lives as belonging to this sense of purpose. Can you envision living your life so that taking out the garbage and doing the laundry is still related to your sense of purpose? Being able to broaden it in this way is a very crucial ingredient of a healthy mind. Have you ever trained your mind? Research from neuroscience leads us to understand that there are two fundamentally different kinds of learning. One form of learning we call declarative learning, which is learning about things. I can learn the value of kindness by sitting down and studying texts about kindness, but this won't necessarily lead us to become kinder. We can teach people the value of honesty, but this will not necessarily make them an honest person. In order to cultivate these qualities, we need a second form of learning, and that is called procedural learning. Neuroscience teaches us that these kinds of learning operate through totally different brain circuits. We need both to produce real transformation. The wiring in our brains is not fixed, it's adaptable, and we can harness the power of neuroplasticity to change our brain. Let me give you one example. This is an example from research that we did where we randomized people to a group that received compassion training for 2 weeks, another group that received training from cognitive therapy. We put people in the MRI scanner before and after the 2 weeks of training. And lo and behold, we see systematic differences after just 7 hours of practice. Our brains can change in a remarkably rapid period of time. The changes that are displayed here are changes in a circuit that involve the prefrontal cortex and the ventral striatum, a circuit very important for certain kinds of positive emotions, which gets strengthened after just this short amount of practice. So these and other kinds of data indicate that the brain really can change quite quickly. It doesn't mean that these changes will last, but it means that they can occur, they can begin, and with systematic practice, they will endure. We view this as an urgent public health need. So we need to start someplace. I would recommend 3 minutes a day. When human beings first evolved on this planet, none of us were brushing our teeth. And yet, today, we all do. This is not part of our genome. This is a learned behavior. And it doesn't take much to start these mechanisms in the brain to change. So we can do this when we're doing other things. We can do this while we're commuting. We can do this as we're literally brushing our teeth. We can do this as we're having our first cup of coffee or tea in the morning. We can do this as we're walking. This can be incorporated in routines of our daily life. So we can nourish our mind, and through it, we can change the world. We can reduce implicit bias that gets under the skin. This is something that we've shown can occur with strengthening connection. We can increase school achievement, and we've and others have shown this with training in awareness. We can reduce healthcare costs potentially by cultivating well-being, as the connections that I've illustrated show. We can cultivate a strong sense of purpose, we can reduce distraction, and we can increase productivity and focus. And I'd like to end with just a 1-minute short period of practice to give you an experiential taste of this. So if you all just sit for a moment, put down your pens and devices, and I invite you to bring a loved one into your mind and your heart. You can leave your eyes open or closed. And for those who are viewing this online, please share this 1 minute with us. And as you bring this loved one into your mind and your heart, cultivate the strong aspiration that they be happy and be free of suffering. And they share the same wish for happiness and the same wish to be free of suffering as all human beings. And you can envision a time in their life when they may have been having some difficulty. And you can say a simple phrase in your mind: may you be happy, may you be free of suffering. And simply notice whatever may come up for you. And then we can do this for many categories of people, including a difficult person. So I invite you to join us on this journey, and the very future of humanity, we think, depends on it. Thank you very much.
I'm gonna try, hold on one sec while I try and shut this thing down. Okay, let's see. Okay, I think we're all set. Let's go back here. So, and we've got two Stevens,
He's in stereo.
okay? So what we're gonna do now, that was just an example, that was very Western oriented view of what we called meditation, but I was just trying to, we haven't done anything like that, so I went off and grabbed it. So what we're going to do now is I'm going to go back and start to review the things that we've done before. Hold on, we're about to get some.
Did you hear that thunder?
Here we go. So this is our website, and this is the resources tab on the website, okay? And down this column here is a lot of things that Ron Cowan participated in, helped to create. We're going to go through that, but I wanted to draw your attention to what's here in the center. This is really we started with an overview lecture. We did subject 1, subject 2, down to subject 10. Okay, that was what we did. That's all in the middle here. And the things over on this side are all little tidbits, I think, of things that are of interest, but they complement, they give you other ideas for what we did in the main course, but they're not mainstream. They're here for you to go look at if you have time or whatever. So just to go back in time and reflect on this, when we were talking about the science side of things, we touched upon, first of all, Newton and him drawing on the studies of Copernicus and Tycho Brahe, and ended up with what he called the laws of gravitation. And this led him to a description of the world that had a profound effect from the 1700s on, where it's still with us today. So we had Newton doing this. In the late 1700s, we had people like Benjamin Franklin with his flying his kite and getting into a study of electricity, very different than what Newton and Copernicus and so forth did with gravity. And there was a series of lectures given by in London that popularized experiments on electricity and magnetism. And the net of these experiments was that this led to Maxwell looking at all the experiments and codifying all this in the 1860s with what we called electromagnetism, that electricity and magnetism are indeed coupled together. And that leads us to a different description of nature than gravity, a description based on something called a field, an electromagnetic field. Just like when we had a gravitational field, it encompassed some aspects of space. So the electromagnetic field had different qualities having to do with charged particles and charges and things attracting and repulsing. So at the same time, what was of interest to me was we had these mystics start to show up. So we had Helena Petrovna Blavatsky, who was very much of a mystic and created this Theosophical Society. And two members that came out of it, Charles Leadbeater and Annie Besant, that carried out a whole series of observations in the 1890s on up to even the 1930s. And they did all this through meditation, through a very different technique than what Newton had done or what Maxwell had done. They dealt with meditation, and they meditated and were able to see down into the microcosm. And they had a particular quirk of what they did when they looked at something such as hydrogen. Hydrogen, as we now understand it, has one proton in the nucleus and one electron. They never saw pure hydrogen. They always saw a pair of hydrogen atoms. So there was always two nuclei and two electrons. And in fact, what we see in the world around us today is that we don't see raw hydrogen. We see the hydrogen always bound together in pair. But Leadbeater and Besant saw everything in pairs. So when they went to carbon, carbon has 6 protons in it and 6 electrons running around, 6 protons in the nucleus. They always saw a pair of carbon atoms, always seeing a pair. And this led them to look at, they went to different museums and they looked at all the elements there, and they ended up generating a periodic table of elements where they discovered what we call today isotopes. So they discovered in the nucleus, there's a certain number of protons and a certain number of neutrons. And the number of protons gives you the atomic number for the element. But the number of neutrons can be different. You can have a particular number of neutrons. For example, for hydrogen, you can have no neutrons, and that gives you hydrogen. You can have one neutron to go with the proton, and that gives you deuterium. So that's a pair of particles, deuterium. And then you can have 2 neutrons and 1 proton, and that gives you tritium. So you have 2 different isotopes of hydrogen that they discovered all by themselves on these observations. And this was before anybody had discovered this. No one knew that there were isotopes out there. And this led to having things like hydrogen have a mixture of weights. Most hydrogen that we see has just one single proton there in the nucleus, but there's a small amount that have 1 neutron. This gives us deuterium, and a much smaller amount that have 2 neutrons that gives us this tritium. And they observed all of this and codified it and wrote it all up in their observations. Now, at the same time, what was interesting to me while they're doing this, it was all through the latter part of the 1800s, in places like London and Paris and Berlin and New York City, there were mystics there. There were people there. It wasn't simply the Blavatskys and the Leadbeaters and Besants. There were many other mystics running around that were doing seances and allowing people to see into the future or to conjure up spirits. And this was just an integral part of society that we've lost. That it was highly popular. It kept on going right up to World War I, and then it seemed to really die out a lot. It had a huge interest because people could participate in this and, for example, talk to loved ones that had just passed on, or they thought they were talking to their spirits. And so it goes. We had, for example, Carl Jung was born in 1875, and Jung had this very mystical side to him where he felt that underlying everything was a collective unconsciousness, a mystical essence that coupled everything together. And this is what he kept talking about, and this led him to come up with the notions of archetypes and everything else that he did in this realm. So, in his own way, Jung was highly mystical. So this takes us down to what in the world did Ron Cowan do? Well, Ron ended up reading what Leadbeater and Besant had done, and he carried out a series of observations that confirmed everything that Leadbeater and Besant had done, but he did many more observations beyond what they had done, okay? And I'm gonna just go and review that here in this thing here. If I can open this, that is, let's see. Here we go. So what we have here, let's see, what is all this junk over here? What we have here, this is a summary. We pick up really here in the 1970s. That's what we're talking about, the last 5 decades, where physics has basically seemed to have stalled, to have not really made the progress that it made in the previous period of time. There is a lot of activity here that's created something called the Standard Model, which describes fields and forces and particles and so forth. And that appears to be, a great intellectual accomplishment, but it seems to be missing a lot of stuff. And these are not minor misses. And really no one seems to know where in the world we go. So let's take a look at what we saw here. We go here to this. So I'm going to skip over this for the time being. The main thing that we came up with here, let me just go run down here a bit. Is that there's a lot more matter and energy out there than people realized. In the 1930s at Caltech, an astronomer, Zwicky, looked at some spiral galaxies, and he asked himself, they're rotating, and if they're rotating at a certain speed, then let me plug in an average number for the mass of each of the suns that's there in this galaxy. I'll put in an estimate for the average number of stars that is here, and it's spinning around its center of mass, and what happens. And he discovered that if that's all that he saw for the mass, that this galaxy would just go flying off in all directions. He was missing a lot of mass, and he went back and did a variety of calculations and concluded that he needed at least 5 times the amount of what he called dark matter to be present in this galaxy versus matter, which is what he had assumed. That's not a minor miss. That's a pretty big miss. A woman, Vera Rubin, in the 1970s did a whole series of calculations that were all published that confirmed this, and they realized, they called it dark matter, but it's really transparent matter. You can't see it. It's someplace else, but it's vibrating, it's oscillating, and again, it's far more than we have, than we have for matter. The other thing that came up was what was called dark energy, okay? And this was observed by an astronomer over in Arizona in 1912, and in 1924, Hubble did lots of observations following up on what Slipher had done. And he discovered that all of these stars that we see out there, all of the galaxies, are all moving away from one another, and they're driven by some sort of unseen energy, which he called dark energy. And this is 3 times as energetic as the dark matter, the dark energy, and far more than the matter that we're dealing with. So we're faced with this conundrum here, that that we ended up by spending all of this time, hundreds of years since Galileo, Copernicus, everybody else, studying the universe, and we've been discovering basically 5% of it. The matter makes up 5%, dark matter makes up 27%, and the dark energy makes up the remainder, or 68%. Now, we've learned from physics that matter has two sides to it. It has a particle side and it has a wave side, or a wavelength, or a vibration. So matter is always vibrating. We remember what Einstein had come up with, that energy is proportional to mass, or what Planck had come up with, that energy is proportional to the vibrational frequency that you deal with. So when we talk about matter or energy, we're really talking about vibrations. And the amount of vibrations that are out there is really 95%. It's 19, 20 times as much as all the energy or vibrations that we see from matter. So where in the world is all this vibration taking place? The conclusion was that it has to be taking place in other dimensions that are in some sense close to us, but they're not in our space-time. So here is our space-time here. And this is the real contribution that Ron Cowan came up with, was this particular picture here showing we've been studying the space-time area here for centuries, hundreds of years. And yet right next to us is a second space-time that's in a separate four-dimensional space, a subspace, and it ends up having 27% of the energy associated with it, while this only has 5%. And down here, we have these other six-dimensional spaces that are right next to these spaces. And these spaces here contain, and this is the key thing, they contain information. And the information can actually control what happens in the space-time here. The key thing is that we talked before about having matter, and matter being both particle and being wave-like. When you look at the fine print, it's actually the wave-like side that actually creates the matter side. It's a little nit, but it's important to keep in mind that it's really the vibrations that lead to creating the particles or our bodies that we see around us. And so those fields.
Would you agree with the statement that I remember from spiritual teachings, that matter is just energy that is vibrating at a slower rate than what we think of as pure energy? That's just vibrating. Rapidly.
Yeah, I mean, I don't know that it's vibrating at certain frequencies. Okay, matter has its own wavelengths and its own vibrations at certain frequencies, but again, the dark matter over here is 27%. So this is only 5%. So it's 5.4 times as much vibrations occurring over here. And the dark energy, we saw everything moving away from us, that's actually space itself is vibrating. The space that we see around us has vibrations associated with it. And that is far greater, that's 68%, whereas this is only 27%. So it's 3 times the amount of energy associated here.
We should have those percentages there.
Yeah, we can put them in. But the thing to keep in mind, there's another deeper thing here that comes up out of this that's really fundamental, which is that at the bottom of everything, we talked about having particles and particles having wavelengths or vibrating. The key thing to keep in mind here is what happened in the 19th century, early 20th century, was people realized that even though they saw things around them that were, they thought continuous, a continuous electromagnetic field, or a continuous wave in a lake for water, or whatever. When they actually looked at it at finer and finer scales, they realized that as they kept dividing it, it was made up of discrete particles, okay? That there's what's called a quantum, or a fundamental discrete particle, that underlies all of these different phenomena. So in particular, what we think of as particles that were in the nucleus of the atom, for example, they're all discrete. We can't chop an electron up into half an electron. The electron comes in one size, and that's it. The proton comes in one size. The neutron comes in one size. The neutron can be split into a proton and an electron, but those can't be split. And so it goes. And the thing that goes along with this is when we deal with space, the space around us, that space is quantized. So there simply are space compartments. And these discrete compartments are what the particles hop between. When we see things moving, they hop from one compartment to the adjacent compartment, and so on. And so everything is discrete. At the very bottom, one of the most fundamental things is that everything is discrete. But when we look at space, you could think of it as a foam. Okay, so all of these little space compartments together, as we back off from looking at them very closely, it forms a nice sea or a nice ether all around us, and it looks continuous. There's no lumps to it. But when we dig down deep, down to these really small dimensions, this is what Ron Cowan observed, that everything is made up of these discrete entities that are at the very bottom. Now, one of the things that comes with this is that the walls of the space compartments are lined with what Ron observed. He called them information blocks. So when I go down here to this picture here, we talk about information, okay? And the information that's there is in all of the compartments of space. So it's all around us, everywhere, and it resides in these compactified dimensions that we can't see, but they're all around us as well. And these things create the fields, which in turn create the particles that control everything here in what we think of as space-time. That this is how the world works. The thing to keep in mind with this information is, if you ask yourself, well, it's everywhere, and it contains the algorithms and the data for running the universe all around us. It's expanding the space compartments to create this dark energy. It's creating the vibrations in the subspaces for matter and dark matter that create the energy that we see there. So it's really all powerful in terms of what it's doing. It's also omniscient, because the algorithms that it's dealing with, while they're distributed across all of space, they end up being universal and controlling everything. And so, in some sense, we have both good and evil controlled in this information here. Or to put it differently, this information really appears to be a good candidate for what Jung called his collective unconsciousness, or what many religions call God. It has all of these attributes of doing everything. It's all around us. It does everything. But we're gonna leave that notion for a minute. That's an interpretation out of this. The other side of things that Ron Cowan came up with in looking at all these things here was that this 10-dimensional subspace has matter in it, and the dark matter is over here. What's the difference? Matter is made up of what he called subquarks. The subquarks, an example is an electron, has 10 strings wrapped around it. A dark matter subquark over here has 5 strings wrapped around it. So the strings are always vibrating, making the electron vibrate or making the subquark vibrate. Go ahead.
Show the image of that.
The images, I think, are down here, I think. Hold on. Yeah, here we go. Here are and Leadbeater and Besant saw this, these subquarks, okay, which they called universal physical atoms. There's nothing, this is it. This is the bottom. There's nothing small in this, but this is, for example, wrapped around an electron, okay, and it's vibrating like crazy. And so the vibrations are creating what some mystics have called the music of the spheres. That there's all kinds of noise here, all kinds of harmonies, every frequency you could possibly imagine. This incredible amount of energy is making these things vibrate. Other people, here's an example here, a chap named Babbitt in 1878 went through this and with meditation, and he observed, here's his picture of a subquark, which looks to me to be remarkably like what Leadbeater and Besant saw.
Each one of those strands is, it's like a fractal. It's composed of more strands, like if you blow this up.
Yeah, we'll see that with what Ron did. You'll see there's a lot of texture to this, and that they're even though these look like solid strands, you'll see in a second.
They're made up of strands.
Yeah. So here we go. In fact, let me just go back to. Right. So what did Ron do? I think he started in the 1980s. Bruce can correct me on this. He must have. But he started to be very systematic in these observations. And so he duplicated these observations of these earlier observers, Babbitt, Leadbeater, and Besant. And he saw there were 10 strings. They're closed. The strings are all closed on one another. So they're called heterotic. And they make up necklaces. And they might be made up of neutrinos. It wasn't really clear what in the world makes up these things here. But the main thing that Ron observed was these information blocks that contain both the algorithms and the data that are just covering all the walls of the space compartment. And they're covering all of these particles, all of these subquarks, everything is covered there. And these information blocks are always sending out scans. The scans are in these compactified dimensions, and they're scanning, and responding to changes that are occurring in the positions of the things around them, and so forth. And this explains how the whole universe works. And it's in some sense, of course, you need. We haven't written down any equations yet to describe how these scans work. The scans appear to be happening at faster than the speed of light or instantaneously running through the entire universe. But they hook everything together so that everything knows where everything else is around it.
Can you show the image of the little squares?
The image of the little squares.
Of the information blocks.
Oh yeah, yeah. Let me see if I can do that here. Yeah, here we are over here with Ron's. Here's a picture of an electron. Here's the 10 strings, but the 10 strings are wrapped around the electron. The electron is a torus. It's a donut. It has a hole through the middle. It's a tall donut. Here we're looking down on top of it, and when we look down on top of it, we see it's covered up here. We see these information blocks that are covering this entire electron, but they're also covering the walls of the space compartment that this resides in as well. If I go down here and look at these other things, these are, for example, here's a proton which has 9 subquarks in it, or 3 quarks, each of which has 3 subquarks in it, which Ron observed. Leadbeater and Besant had similar observations. Here you start to see some of the structure that Ron observed, and Leadbeater and Besant observed this as well, that there's lots of granularity here in these. What looks like a nice string has all kinds of curlicues to it here. And here's an example of it. You can see here's what looks like a string, but the string is wrapped, has another string wrapped around it. And if we looked at the thing that's wrapped around it, we see that in turn is following a string, and it goes on and on. There's like 7 levels of these things occurring here that Ron observed. Did someone have a question? Judith?
I was wondering if, like the dark matter, we have the visible and the invisible. So is that, how do I put it? The next dimension?
Yeah, it is. Just a sec, I want to go back to, where did my presentation go? Hold on.
Resources. No.
Here. I'm gonna go here. I don't know where this went. Here we are. Okay. So your question was, I've shown this here. If I looked at any point, like right at the end of my nose, it says that there's 26 real dimensions. So I need 26 numbers, 26 coordinates to specify where the end of my nose is. It turns out that 10 of those numbers make up reside in what we call the matter subspace. So 10 of the 26 dimensions just have matter in them. Oh, right next to it, there are another 10 dimensions that have dark matter in it, okay? And finally, there's 6 dimensions down here, the very bottom, that synchronize everything. So repeat your question again, Judith, so I can make sure to try and answer it.
I was wondering if, okay, let's say the 10 dimensions matter is what we're living in. I'm seeing you, you're seeing me, we live here. In the 10 dark matter dimensions, could that be, when we talk of, in the Bible or anything else, we have the visible, which is us, and the invisible. So if you're talking like Sylvia Brown, when we leave here, we go to the next dimension. I'm not saying that dark matter would be just one dimension. It could be 1,000, it could be 1,000,000,000, but would that invisible dimension be in what would be considered the dark matter?
Sure, okay. So here's what Ron observed, okay? He observed that in this dark matter here, that it's this is where what we would call souls reside, or spirits,
Okay.
or angels, okay? And that
Well, that would answer my question.
that each of us has 7 major chakras.
Mhm.
Okay, the chakras themselves are made up of dark matter. And Ron observed this, and he put this into his, if I go back to my book here, hold on.
Okay.
When I try and hop around here we go. When I go
That's
down here.
said to be the energy body.
Yeah,
What we
hold
think
on,
of as
hold on.
the
Here we go.
energy.
Here's
Yeah.
his book. This book here, The Path of Love. This picture on the cover, which happens to be in color, is of the crown chakra. Okay. And so each have a crown chakra. And he has pictures of not simply the crown chakra, but the other 6 major chakras, okay, that are here at the end of the book. He did not really spend any time on that, but what he suggested was when we're born, a soul or a spirit links with us, incarnates with us, becomes it. So it's not, it's linked to our body, but it's in these other dimensions.
Right.
That are right next to us. Let's see, does this do it? Yeah, that are right next to us, okay? And when we die, then it disincarnates, it let go, and it goes back into this realm that's here.
Okay.
Now, these things live forever, okay? There's no evidence that they ever die. And over here, what lives forever are the atoms that make up our body, okay? The different particles live forever. That's all fine, but our body comes together. We're born, we live for a while, and then we die, ashes to ashes and dust to dust. So
Right.
the only thing that lives forever here are the particles, whereas over here, the spirits live forever, and the spirits can live for incredible periods of time, trillions of years. And so they develop incredible, and remember, they're evolving. They're not
Those eons.
it's inconceivable how long they're there. So they end up evolving over time with incredible philosophies and views of the world and anything that you can imagine. This is why they're called in many ways godlike, because it's really inconceivable what in the world they're really doing, what they're, it's like you could think of us as being ants looking up at a human being, and we can see the human being, but we can't really conceive of what in the world is that human being thinking. It's just beyond us. So the hierarchy is this, okay, that this lives forever, okay, and then these things, the particles over here are the only things that live forever. Now, Bruce, did you want to say anything about, I don't want to get too far ahead of the curve here, but anything about what Ron observed? Am I overstating, understating, being incorrect on any of this stuff?
No. The only thing that I guess I've said this a few times before, the thing that really he was really impressed by was the fact that he was tracking an electron traveling through space, and it disappears and expands through the whole universe and comes back a little bit further along the way. And from that expansion, it has these little bars of information. So what I sort of got from that was that the whole universe is in union with itself. Everything is not separate in a certain way.
Yeah, when you deal with control, when you try and couple systems together, you discover that if there's delays that occur, you end up with the possibility for positive and negative feedback. And rest assured, that is not a good thing to have. So what has been built in here is the universe is very tightly coupled. There's really no delays here, and these scans that take place go to the far realms of the universe. But really, the things that are close or nearby are the things that are most important. Okay, but it doesn't mean that something that's in 87 galaxies away isn't responding. Okay, it is what's taking place here. But another difference here is that modern science has really focused on these activities. So there's lots of instrumentation for physics, for chemistry, for biology, okay, for measuring all kinds of things here. We have virtually no instrumentation over here other than going into meditation and trying to understand what's going on with these chakras, what's going on with the associated couplings between the chakras, there's no meters that are there. Remember, Ron is doing all these observations simply on his own, and he happened to be a very good artist, so he did very nice sketches of what he saw, but he doesn't have any, to 7 significant figures. This is how big this is, and this is how big that is. It's all highly qualitative. We need instrumentation. We need, for example, people have taken pictures where they try and capture these 7 chakras going up and down from your root chakra to your crown chakra. But we need much better instrumentation here. And hopefully what will come out of this activity that Ron worked on is this will stimulate the physics side of things and engineering side of things to come up with the instrumentation to try and actually see what in the world is going on in these other realms here, okay? We really can't say anything. We've spent all our time dealing here with the 5% of things, and this is already 27%. This is a much vaster realm. And the thing to keep in mind here with this is that Ron observed, again, these chakras that are linked to each of us, those giving you a soul or a spirit. But he also went out into the realms of space, and he observed that he saw this, what you would call dark matter, just floating there. But sometimes the dark matter would hit another piece of dark matter, and he observed tubes of dark matter that were, hundreds of kilometers long, that were out there in between the stars. Okay, and this is what gave the mass to the extra mass to the spinning galaxies that we have all around us, is the dark matter that's out there in between the stars in space. Okay, and we had, as an example, Ron described this. He said that at some point he was on another planet, and the sun for that planet, the solar system there, the sun went nova and blew up. And so it blew up Ron's planet, and Ron was living there perfectly happily, and he went flying through space for who knows how many eons. And at some point he landed on Earth, okay? Well, while he's going through space, he becomes inactive. He just is not doing anything. When he lands on something like Earth has some heat, or can generate some vibrational energy. And this could couple to this dark matter. The coupling between the matter and the dark matter appears to be through gravity, or equivalently, if this is hot, if this is shaking, then this will start to shake as well. The dark matter will start to vibrate, and this brings it up in its level of sentience. Remember, Ron was always there as a personality, and so he became sentient, and he went ahead and I believe carried out a variety of interesting experiments to try and move evolution along on Earth. And this would be not an uncommon thing. And there were other entities that also landed on Earth that he talked about, other dark matter entities, he called them mind forms or sentient entities that were there. And over here for matter at that point in time, we had for several billion years on Earth, we just had bacteria, which are single-celled creatures, okay? And so they're called prokaryotes. And at some point, though, the single-celled creatures smashed into one another and formed multi-celled creatures, which we called eukaryotes. So I have to believe that Ron and his other entities that were there were involved in trying to get the eukaryotes created. And by doing that, you ended up with a chance for a lot greater diversity and the chance to grow all kinds of specialized functions. So you could start to grow eyes and arms and legs and bones of all sorts. And in the meantime, these things over here were linked to whatever it was, and they were actively involved and trying to encourage things. And so it's an amazing story of how, you know, things evolved here with the symbiosis between matter and dark matter, or the spirit side of things interacting to take the matter and drive it from simply in the chemistry side of things just being a little bacteria here, and getting the bacteria to start to form RNA, DNA, and then starting to form these multi-celled creatures that eventually became us. And of course, if you have forever to do this, you're not in a rush, and so it goes. And it's hard to imagine doing these sorts of plans, but you know, if you have a couple billion years, what does it matter? Might as well do this as anything else. You know, see what happens. So,
I'd like to suggest another scenario.
sure.
This is when talking about some of the very advanced meditators. Basically, what happens is that you have a nonverbal, intuitive understanding of the whole universe. Like it's just, and when you're in connection with another person who has that type of reality in their real life, it's just taken for granted that it's there. So in terms of meditation and realization, there's a non-verbal understanding of these laws of the universe. For example, time is not as real as you think it is. The intuitive mind understands their whole lifetime and their previous lifetimes in one nonverbal thought. So it's like a grasping of the reality behind the so-called reality, which most people can't even imagine. But when it comes to the experienced meditators, like, you know, like a Dalai Lama and so on, like they have an intuitive grasp of all reality at once. It's not separate. Now,
Right.
when you talk to somebody like the Dalai Lama, they're mainly concerned about love and compassion and you know, alleviation of suffering. They're primarily focused on that. But at the same time, they actually have an intuitive understanding of all levels of reality. And it's just a natural state of the mind.
Yeah,
So,
what the physicists have done is they've realized that there's a universal wave function that vibrates throughout the entire universe and encompasses all possible outcomes of what in the world is going on in the universe. And it's sitting there running all the time. And so apparently people like the Dalai Lama can sense this, and
Right.
they can see at an incredibly deep level everything that's going on everywhere around us. But what goes with it is that Bruce touched on time, and I pointed out there's 10 dimensions here. Well, there's 3 for space here, but there's also 1 time dimension. Here there's 6 space dimensions, no time dimension. So the trick that Ron came up with that made sense was we have 3 space dimensions here, and then we multiply all of them by the square root of -1. Don't ask me why, but that seems to work. And that gives us a second set of 3 dimensions, okay, that are all spatial dimensions. There's no time here. So we actually have 6 spatial dimensions, 6 real spatial dimensions, or if you will, 3 spatial dimensions, and then 3 more multiplied by the square root of -1, which basically rotates them perpendicular to the first 3. Is what this suggests. Similarly, down here for this one, we have 6 space dimensions, no time dimension. So we have 3 of them, and then another 3 multiplied by the square root of -1, and similarly here. So we have a total of 24 space dimensions in this picture and 2 time dimensions, 1 time dimension for matter and 1 for dark matter. Well, we have 24 dimensions, but they're each in different 3-dimensional subspaces. So we have 8 3-dimensional subspaces, spatial subspaces, and then we have these 2 time dimensions, not 1, but 2. Now, the thing that's crazy about this that comes out of this is that time, effectively, when you're dealing with space, I can step away from time. Okay, time is again just a different dimension, sitting there running along. So I can step out of time and then step back in at some other point. So I can see here's how I'm living today. And in an earlier life, I was living as this person, and in an earlier life, I was living at that person, and so forth. I can step in and out of time, is what this suggests. The space, the time dimension here for dark matter, what's even crazier is it appears to be, again, all these dimensions are multiplied by the square root of -1. Well, for time here, the time around us, it actually is the square root of -1 times the speed of light times time. Okay, so if I multiply the square root of -1 by the square root of -1, I get -1. So I end up with 3 spatial dimensions, which are all multiplied by the square root of -1, and then a minus the speed of light times time. Or in other words, time appears to be going backwards for the dark matter that's over here. Whereas here for us, it appears to be going forward in time. Time is indeed very different here from what we're dealing with, okay? So these are all things that Ron observed in going through these things. The other thing, just skipping through this to see if there's anything else I want to highlight.
One thing I wanted to just point out is that this is only such a dilemma because of the way, because of the dichotomies that we put things in this culture. I think in other cultures, they have a much more straightforward understanding of this. It's not, it doesn't need to be as complex and arcane.
Right.
I think a lot of indigenous cultures, we've talked before about shamanic practices, where they just take this for granted. And it includes things like zooming in and zooming out for scale. You know, like they just go into a trance and they see the microbes of an illness in their patient's energy field. And they kind of talk to the microbe and try to get an agreement with it. It seems to work. Their trance images look like our microscope images. You know, they don't have any training in biology or medicine or anything like that. But if they draw or paint their trance images, it's the same thing. They are seeing the same reality, and it's not that far-fetched. It's, you know, it's very commonplace. It's very ordinary. And one example, the Aboriginal art of Australia, of the original people there, their artwork is depicting this kind of reality. And to them, they're just, it's realism. It's not imagination at all. They're painting what they see because they're trained to see that reality as children. And a lot of their paintings depict like after images that, you know, like those Carillion or Cerulean, how do you say that? Photographs that show where a car was parked. You could still read the license plate, you know, like an hour later, if you have the right kind of equipment to photograph it. The after image, after the car has gone away, that's what their paintings look like. They're painting energy. And there's often these concentric rings of it, and they're seeing a timeline. That's how they meet each other in the desert. You know, they send each other messages. Let's meet there, you know, after 3 solar cycles after this lunar cycle. You know, and they have a way of working it out that they get there more or less at the same time, and they're trekking hundreds of miles on foot through, you know, to us, it's just barren landscape. It's just deserts. But they notice different things because that's how their culture shapes them.
Now, then in these other, you know, compactified dimensions, these are the higher realms. So we have what you're missing here is here's a picture, a 2-dimensional picture of one of these 6-dimensional realms here. Okay, and here's an animation. Here we go. To give you some idea. See, these things are changing all the time. And then there's the music that comes with this, the music of the spheres, that these things, remember, are vibrating. All that energy that we talked about that's here in these realms is really here. And that's what people are sensing. Now, Ron and I work together to come up with a framework that matches what we would call Western science, okay? The other people don't have that framework. They have some other framework. So they're just dealing with this picture here. That's all that they have. And for them, that's good enough. It'll do everything that they need to do to be able to go cure a disease, or to go find someone out in the middle of the desert, whatever it is you want to do. And this is their world. It's just a different set of words describing what in the world is going on as they see it happening around them. And they get this through, again, intense meditation toward being able to get there. So we had this other one here too. This is just bits, ones and zeros that are streaming. So the scanning that's taking place and the bits that are flying around to synchronize everything, you know, this is just a picture that suggests what it might look like. We're thinking of adding this to the website, so we'll have a little background for it, you know, everywhere.
And these diagrams.
Yeah.
Art, can I ask you a question about the space-time equation?
Yeah, go ahead.
You just muted.
Oh, hold on, Steve. I muted you. Hold on. Okay.
Huh?
How do I
He has to do it.
I ask you to unmute, Steve. I must have muted you. I'm sorry. Steve?
Yes, yeah, can you hear me?
Yep,
Yes.
we can hear you now. Yep.
We can't-
Could you blow up this dimension thing that shows space-time on the lower left there?
This thing?
Yes.
Okay.
On the line that says space-time under dark matter.
Okay.
What is the very first left side of the bottom line of the space-time dimension there? What is that?
So it says 10 dark.
Yeah,
matter.
down.
So the 10 dimensions are here in this box.
Okay, I'm going down. If you see the box that says space-time 4 dimensions?
Yeah. So
What
that's
line
what it
below
says.
What is
Underneath it is I took I, which is the square root of -1, and I multiplied it. That's a star. Okay. And I multiplied it by the dimensions over here, which is X, Y, Z, and ICT. Okay. The dimensions, let's see if we can, here we go. Can you see this better?
Yes.
Okay, here's what the problem is. We have space. So space has dimensions of meters. So we have X, Y, and Z. Now we have time. Well, time doesn't have dimension of meters. So I've ended up multiplying it by the speed of light. The speed of light is meters per second. So meters per second times seconds gets you into meters. Okay, but I can't see time. So I've ended up multiplying it by square root of -1 here. It effectively rotates it away from the 3 dimensions that we have around us. So time is in some sense perpendicular to the 3 spatial dimensions. Now over here, Under dark matter, I have the same 4 dimensions, X, Y, Z, and ICT, and I multiply all of them by the square root of -1. So I'm rotating all 4 of these dimensions to be perpendicular, to be 90 degrees away from what we have here. That's what this multiplication does. So if I do that, I get IX, I get IY, I get IZ. But now when I multiply I times I is the square root of -1, times itself gives me -1. So I get minus CT here, or if you will, C, the speed of light times the quantity minus T, minus time. Here we had time being positive over here for matter. Here we have time being negative for dark matter. That's what's crazy. The thing is, you have to basically, sometimes when you have crazy stuff like this, it's better to just trust the math and see what the interpretation is of this. So what happens with the interpretation of this was we used this later on when Ron went ahead and looked at how the universe bounced, okay? How it expands. Right now we're in an expansion phase of where we're at right now, but eventually it'll stop expanding and turn back on itself and bounce. And when it bounces, then we'll create a new universe, another cycle around us, okay? Well, the thing that we saw here, if you remember, you remember the Asimov story that Asimov had, everybody was eventually moving off into hyperspace, was what he said. Everyone was going off into hyperspace, and pretty soon there was nothing left in this matter subspace. All of the matter had decayed. Everything, all the black holes had evaporated into nothingness. The matter that we have here, even though they have protons and neutrons and electrons, they'll eventually evaporate to nothing. There'll be nothing left here, nothing whatsoever. But it'll take a long time to get there, okay? So in the meantime, what was happening, if you follow what Asimov was talking about, was we had people here and they each had souls. The souls live over here. So the people were uploading their souls off into these higher dimensions. That's still there, but it's not in this space. This space is gone. But this space here now, since there's nothing left here, there really is no notion of time over here anymore. What could there be? There's nothing here. Everything is evaporated, everything is dead, and so forth. But here we have time, which is going backwards. So we could go backwards in time for trillions of years as everything is starting to come back together and bounce. Okay, and when it does bounce, when you create this new universe there out of this bounce, then we start to get time created again, and we start to go forward in time. So that's one reason why I want to keep this minus time here. It's a useful little trick to keep track of the cosmology of what's going on.
And where did the square root of -1 come into this equation?
From God. I have no idea. That's why I gave you all of these. Hold on, let me go over here to, what did you do? Expanded this?
Yeah.
Yeah, so here we go here. Hold on, I'm gonna do one thing. I hope I don't get killed doing this. I'm gonna go here to science. This is where people talk about how mathematics is unusually effective in how it describes the world around us. You know, no one understands why that is the case, okay? But the net of it is, I'm just trying to load this thing, see if this will work. Yeah, here we go. Take a look at some of the videos I put here. I just have to load.
we're realizing we're going about this the wrong way. We are going to make it more efficient. We'll just put some image links here that will go to the videos.
Yeah. And in part, we're just let it continue loading. You'll see what's going to come up in a second.
Bart, what I'm saying, who is this, you, or did someone else come up with this square root of -1? Somebody had to create that.
The square root of -1 comes out of trying to solve quadratic equations, okay? Which you probably ran into when you were in middle school, okay? So when you have, for example, x squared equals 4, that's a quadratic equation. And it has two roots, x equals +2 and x equals -2, okay? When I have the equation x squared equals -4, okay, then there's two roots for that. X equals +2 times the square root of -1, and x equals -2 times the square root of -1, okay? It isn't a luxury. If I want to solve quadratic equations, I need to come up with these so-called imaginary numbers, okay? So what I have here is a very brief history of complex numbers. Here we see the square root of -1, okay? And up here, this is a whole discussion of how people tried to solve quadratic equations, cubic equations, quartic equations, and then they realized that they couldn't solve anything beyond quartic equations for a very deep reason, okay?
Well, Bart, but using your example of the square root of 2, are you saying that those two answers you gave are the only two answers?
Yes, yeah.
Okay, I'll give you another answer. The square root of 4 is 1 times 4 or -1 times 4. I'm just, creating, when you do this add this multiplication entity, in my mind, we don't have a square. Okay, a square denotes, I mean, this is from Pythagoras dealing with squares. He took physical squares, so.
No, not a physical square, it's a power of when I called it squared, it's simply the power of 2, okay? So I'm multiplying something by itself, x times x,
Right.
which is noted by x squared, okay?
Right.
But it's not the square of Pythagoras. It simply is a bad use of jargon to say that x times x is x squared. That I have x times itself. So I'm looking for what x equals 4. What x times itself gives me. How do I get to 4? And I can only think of two ways to do it. Multiplying 2 times 2 gives me 4, and -2 times -2 gives me 4. When I have x squared equals -4, I can only think of how to do it by having +2 times the square root of -1 or -2 times the square root of -1. When I multiply those things together by themselves, I get -4.
I understand how your equation works, but I mean, perhaps this is semantics, but to my mind, where you have x times itself equals whatever y, that doesn't include yet another entity, which is, in this case, times the square root of -1. That's just adding something else. So that's not.
Well, the problem is this, is that if I have x times x equals 4, okay, then I don't need to do any gyrations with numbers. I can take I can just say, well, I'm only going to deal with positive numbers. So x times x equals 4 means that x always equals 2. Okay. But I say, well, I want to be generous and I want to include kind of all possible numbers. Well, that means that I would go include negative numbers as well as positive numbers. That's my choice. So if I include negative and positive numbers, then x times x can be either +2 or -2. Okay, that's up to me as to how I do it. So when I take x squared equals -4, this is again, I could say, well, there is no solution to this.
Right.
I'm only using plus and minus numbers. There is no solution. End of story. But if some people found that not very satisfying, so they said, I'm going to include a square root of -1 in this. And you can look at this video, which is really a great video here on the website, and you'll see that this led to all kinds of things. And for whatever reason in physics, the square root of -1 appears to simplify a lot of things that happen when you deal with the mathematics that are underlying all this stuff.
Maybe we should start with this video next week.
Yeah, we can do it. Yeah, I understand.
Well, my question, I guess, is that in the world of physics, which we think of as that which is real, is the square root of -1 something that is real? If so, where do you see it? Where can you find it that it's something real?
Well, this is where, remember, I took, if we go back to these pictures, hold on. Okay, I took this to be real, X, Y, Z, and then I said, time we can't see, so I'm going to just multiply by square root of -1, making, in some sense, time orthogonal or perpendicular to our 3 spatial dimensions. That's what I did here. Okay, down here, I just have 6 spatial dimensions. I told you that I took 3 of them and multiplied each of them by square root of -1. And then together, that gave me 6 spatial dimensions. 3 are real, 3 are entirely imaginary. Over here, same thing over here. So what's left here as an exercise is one of, I just view it as instrumentation, okay? How in the world could you go off here and measure what's going on in these other subspaces? So far, all we've built is instruments that work in the dimension of space-time around us. We haven't built anything that runs over here yet. Any cameras, any meters, anything whatsoever. And similarly down here. And I've already argued that down here there's all kinds of actions taking place, synchronizing stuff, all kinds of waves flying around from this particle to that particle to make sure that everything operates correctly. So there's a huge amount of activity happening here, and we don't have any measurements whatsoever of this stuff.
Well, why did you add the square root of -1 to that which we can measure?
Because my gut is that it's the right thing to do. Okay. That having been around the block on this in a variety of other ways, I sense that this is the right thing. Okay. Just like I sensed here that the square root of -1 times the speed of light is the natural dimensions here for this other dimension, which we call time. Okay. It isn't time, it's time, what we call time multiplied by the speed of light. Why do I multiply it by the speed of light? Because that's a natural unit here for the space-time that we live in. But there could be some other number that works just as well. Okay, and then why did I multiply it by the square root of -1? Because when I do various turning of the cranks of different formulae, everything comes out to be very simple to do. It's a very natural thing. So I'm being told through the mathematics to follow this path and not try and do some other crazy things. Don't ignore it. But we're always dealing with 26 real dimensions, 2 time dimensions. That's what's crazy. One here that's imaginary and one here that's negative. You could go figure, okay? 2 time dimensions and 24 space dimensions.
Okay, but in your description here of X, Y, Z, these are things that are measurable, and
Right.
time is
How
measurable.
do we measure time?
How? Look
Yeah.
at your watch. You can measure it.
No, that's a clock. That has nothing to do with time.
Okay.
Time is a dimension. Then I made it a dimension. I gave it a length. Okay, multiplied it by the speed of light, meters per second. So okay, so I want to measure time in terms of its natural units, meters, not seconds.
Well, okay, but you've added to this equation the square root of -1 and the speed of light squared.
Right. Well, the speed of light is just not squared. It's the thing that you see up here, the 2.
It's a
That's a
footnote.
there's a subscript here.
Oh,
CT equals ICT equals square root. This is square root of -1 times the speed of light times time. That's what the subscript. It's not a power. Here, see the 2? It's there.
It's for the
It's
footnote.
the footnote down here.
okay, okay, but if I were creating this, and pardon my being somewhat facetious here, but if I were creating this and I said, well, it was X, Y, Z plus a vanilla ice cream cone times time, it's like just arbitrarily picking something.
No, I understand. But ask yourself this: how do you see time around you? Do you see it?
I feel it.
I agree. That's my criterion. How do I see time? I have to see it as a unit of length. So I'm the unit of length. It's just that I still can't see it. So that's why I multiplied it by square root of -1 to take it out of the realm of real measurements and off into hyperspace.
But that's you're saying that the only way to measure it is to put it in the form of meters.
Yeah.
Well,
Yeah.
that's just an arbitrary measurement.
Yeah, the reason for using these particular things here comes out of special relativity, okay?
I said it's Einsteinian.
Yeah, that numerous, when people have done things here where they've tried to measure lengths, as you get going faster and faster, you take a meter stick, for example, 1 meter long. As you go faster and faster toward the speed of light, it gets shorter and shorter. As you go faster and faster toward the speed of light, a clock that you have that's sitting there on this meter stick runs slower and slower, okay? So there's something funny happening here, okay? It depends on, again, where you are. If you're with the meter stick and the meter stick's there with the clock, then you don't see any change whatsoever. The meter stick is a meter stick and the clock is a clock. Clock's running fine. But if I'm actually put you into a rocket, and now the rocket is accelerating at 3/4 of the speed of light, then the meter stick from where I'm sitting, I'm not in the rocket now. I'm someplace else looking at the rocket. The meter stick is getting shorter and the clock is running slower. Okay, that's why I put this in here, was to make it match what happens in special relativity. And that's what happens in the universe that we're in. Okay, this has been confirmed by a gazillion experiments that what I just said really does happen.
That's why we should start next week with the video.
Yeah, we can do that. Okay, this is one reason why I decided to go back and repeat all this stuff, but try and do it in a different way, is to get this sort of discussion out in the open. Okay, because these are the fundamental things that is driving everything. The one thing to keep in mind here, what we keep harping on is that the wrong term that physics took was they got hung up on looking at all these particles and not realizing that the particles were also waves, and the waves were all vibrating. And in fact, most of the energy that was associated with these things, only 5% of it is here, and 95% of it is in all the rest of this stuff. Okay. And if that's the case, then we need to have it vibrate somewhere. So we need to go to higher dimensions. That's the only thing people can come up with that seems to make sense. We need more dimensions for the vibrations to actually take place. Having more dimensions, though, leads to all kinds of other interesting things that we've touched upon here. It's at this level. This is so fundamental that things really break down, and
Is it a logical necessity?
Yeah, you're led, you're led down this path because no other path seems to work that can explain this stuff. For example, I've talked here about chakras, and they're residing here, and everybody has chakras in them. Okay, for millennia, yogis and shamans and mystics of all sorts have seen these chakras. Okay, we have yet to have any physicist or electrical engineer build a meter or a camera that can show us what these chakras look like. It took Ron, to draw some pictures of it, but he drew the pictures, but other people have clearly seen the chakras over the millennia. They're clearly there, but there's no discussion of it. It's got to be there for it to make any sense. So,
Are auras in this realm distinct
yeah,
chakras,
believe-
or is that part of the chakras?
I believe, and Bruce, catch me on this, but the auras arise from the remember, the chakras are matter, they're dark matter, but remember, they're vibrating like crazy. Okay, and so that by itself creates an aura or a series of auras around you. Okay, or you've seen pictures in the Middle Ages of paintings where they show halos or auras, okay, over people's heads, different auras. And some people have more auras than others. They might have, for example, the extra auras might show that they have more compassion, as an example. Or they have more of an inclination toward science or mathematics, or they have more of an inclination toward art and music, whatever it is. Okay, so
Right. I'm sorry. Go ahead.
yeah, well, I'm just saying that's what I believe the auras have to do with.
Well, and
The question to me is that
Hey, Bruce wanted to say something?
I was just going to suggest that in terms of meditation, when you get into the deeper levels of realization, you have what they call pure perception. So there's different levels of the mind that see these things directly. So there's a level of perception where watching or seeing or experiencing or relating to chakras is simply a natural phenomena. You don't hear about it very much because there isn't that much interest in it except by the people who actually see them. But it's just a level of meditation, awareness, perception.
Well, if you have person A is looking at person B, and A sees these auras around B, it strikes me that A is thinking that they're seeing these auras through their eyes, which would be visible light. But it strikes me that if you took a camera which is saving that imagery of visible light, they don't see any auras. So that the auras that they quote see, they're not seeing with their eyes.
Correct.
Right. They're not. No, that's really what's going on.
An energy thing.
Yeah. The thing to keep in mind is where I've been heading with this is there's certain things you want to take away that are just absolutely fundamental coming out of this. One is the notion of quantum or things being discrete. So space being discrete, the particles that arise out of the fields, they're all discrete. Okay, there's some basic, you can't keep chopping things up into finer and finer sizes. At some point you reach rock bottom, and that's where you're at. So that's the first thing, is there's a notion of quantum or things that are discrete. The next thing is the notion of all of the energy or vibrations that's there. The only place we can think of where it could go is into these extra dimensions. And we come up with 26 two-time dimensions, which is crazy by itself, and 24 space dimensions, which is broken up into 8 subspaces of 3 spatial dimensions each. And they seem to be paired up using this little trick of the square root of -1. So, so the number 8 appears everywhere in this, which is what shows up as a hint in mathematics, where that's why I took this diversion to talk about things called octonions that operate in 8 dimensions and drive everything. Now, we also talked in the class at the very end about the structure of the space compartments being what we call the hypergraph. So it has to be a graph, which is a set of points and edges to it in 26 dimensions. That's what it is. But if we thought about it for a little bit, okay, it has to also obey all of these symmetry things that we're dealing with here. And that's all buried in the information. The information blocks that Ron saw have both the algorithms controlling how the hypergraphs evolve over time, and also the nature of the hypergraphs. What is it that leads to the edges of these compartments of space? So just as a totally different example to close things, Ron saw several space compartments that were several light years long. One space compartment that had been stretched several light years and that had some material inside it, okay? And in the physics world, this is called entanglement, okay? That's something that's in one place, when I change it, it immediately interacts with something that's in a different place. He saw examples of this occurring over light years, okay? Which was truly mind-blowing. So with that, we're already up to 9 o'clock, 9:04 even, and we're going to declare victory at this point. Get out of this.
Well, I have a question.
Yeah.
We talk on and off, it's a kind of running theme. I guess you could say the dichotomy between notions of cause and effect and synchronicity.
Right.
But it seems that synchronicity might be more causal than we normally think of it being. It's not just
Right, it could be
random
linked.
simultaneous. If time is also running backwards, our whole notion of cause and effect.
Well,
And
well,
I've
well,
often had thoughts like this that I just decided not to talk about.
yeah, no, I'm just trying to scratch the surface on this and say, and just point out how little we know. that I'm trying to come up with a consistent set of observations of what's going on. And by consistent, I mean, I follow things all the way through as much as I can, whether I like the conclusions or not. Coming up with negative time seems to make sense. Okay.
Well, I just want.
For the dark matter, not for us.
Well, part of us is dark matter having a physical experience, right?
Yeah, no, I understand.
And I don't know, I just often wonder, well, what if things are really running backwards as we experience it?
I
What we
understand.
think of as causes are actually effects and vice versa.
Right. I hear you completely. To be continued is all I would say.
Yeah.
Okay. You're
I just
seeing-
want to throw in again that there's levels of meditative awareness where you actually see these things as being normal.
Right. Right.
Bruce, what are the things that you say that you're seeing as normal?
Well, there's a couple of things. First of all, it doesn't happen that often, but I can tune into a level of awareness in my own mind, and I can see chakras. And I know what they mean. I know why they're there. Everything is just naturally known, and there's an interaction with them. It may only last for a few moments, but it happens occasionally. So I know they're there.
Another person?
Are these your chakras or are they someone else's chakras?
Yeah.
They're your chakras. You've tuned into yourself.
No. They're their chakras. Not
Got it.
mine.
Okay.
Doesn't happen that often, but it happens often enough.
Bart, a quick question, just in terms of your formulas. When you had formulas such as equals MC squared, which you were using in terms of trying to do the formula you were doing, what is E and M? What are the measurements that are used there? I mean,
So energy is measured in, again, you start with a consistent set of units. So you have mass, which is measured in grams. You have length, which is measured in meters. And what is the other dimension? I guess time, which is measured in seconds, I guess.
what is E? What is E measured in?
Yeah, so energy is in those units, energy is measured in joules, and joules is a measure of newtons per unit time per second. And a joule is where I move 1 gram, 1 meter. Trying to think at a specific velocity, like 1 meter per second, that sort of thing. I'd have to go back and look, but so the E is a measurement of energy or in joules, and then mass is a measurement in grams, and then that's multiplied by the speed of light squared, but that's meters per second, so it's meters squared over seconds squared. So you can see that the energy that we're dealing with, if I just looked on the left-hand side, energy, what are the units of energy? On the right-hand side, the units of energy are MC squared, mass, which is grams, multiplied by the speed of light squared. So grams times meters squared over seconds squared.
Yeah,
And
isn't isn't the square, isn't that a measurement of acceleration of seconds per second? Isn't that, distance per second, a formula for acceleration?
yeah, well, no, that's hold on one sec. I'm just going to do a quick look here on Google.
Like gravity is something like 32 feet per second per second.
Oh, that's the acceleration of gravity.
Right.
Yeah, that is an acceleration, but you talked about energy. I'm just going to do energy units and we'll just see what I come up with here.
Ergs.
They're either joules or erg. So joule is the basic unit of the metric system. Okay. I need meters, kilograms, not grams, and then seconds. So the unit here is that 1 calorie is 4.19 joules, and a calorie is where I would take 1 gram of water and raise it 1 degree centigrade. So that's the notion of what energy is there from a thermal point of view. And then there's many other units of energy. Surprise, surprise.
I'm just trying to go to a place without regard to my total inability to do this. I'm just trying to create in my head how one would just fabricate a formula such as E equals mc squared. Where do you multiply the speed of light times itself as being part of a formula? I can't begin to think of.
Sure. Let me explain. Okay. The mass that I'm talking about on the E equals mc squared, the mass is actually varying. Okay. I kind of walked around this. So there's what's called the rest mass. If I take the mass of something, say it's 1 gram, it's just sitting here. So that's its rest mass, 1 gram. Okay. But when I start to move it, okay, then its mass changes, and the mass changes because I have to divide it by the square root of 1 minus v over c quantity squared, where v is the velocity. Okay, so if the velocity is, say, a 0.1% of the speed of light. Okay, so I'm dividing the rest mass by the square root of 1 minus 0.001, the speed of light, divided by the speed of light. Well, the 0.001 squared is 10 to the minus 6, or in other words, 1 minus 10 to the minus 6 is effectively 1. So when I'm running at, say, a tenth of a percent of the speed of light, my mass is really still 1 gram. But suppose I'm running at, say, 3/4 the speed of light. Okay, so now my mass is divided by 1 minus the square root of 1 minus v over c squared. Well, v is now 3/4 of c. 3/4 of c divided by c is 3/4 squared is 9/16, which is roughly 1/2. Okay. Okay, so I have 1 minus 1/2, or 1/2 now. The square root of that means that the mass is, remember, this is the denominator. So the numerator is now the square root of 2 times a gram. Okay, I've increased my mass by 40%, going at 3/4 the speed of light. Okay.
So the faster it goes,
The faster it goes, the larger the as I approach the speed of light, suppose I'm going at 99% the speed of light. Okay, then I'd have 1 minus the square root of 0.99 c over c, or 0.99 squared. If I square 0.99, it's really 0.99 for all intents and purposes. So 1 minus 0.99 is 0.01. The square root of 0.01 is 10 to the minus 1. So if that's in the denominator, so now my mass is 10 times, going at 99 times the speed of light, my mass is increased by a factor of 10. The mass increases the faster I go. The length, but similarly for lengths, suppose I had a meter stick, suppose I measured the side, suppose this mass was 1 meter on a side, okay? Well, then the length of the meter is now multiplied by the square root of 1 minus v over c squared. Okay, so now when I went to 0.99, the speed of light, then the square root of that, it was 0.01. Square root of that is 10 to the minus 1. So the length is now not 1 meter, it's 1/10 of that, or 10 centimeters. Okay, it's multiplied by it. So the mass goes up, the length goes down, and time slows down. Okay, that's what happens by using that formula that Einstein developed.
So in other words, if I go on this high-speed trajectory through space, I'm getting fatter and shorter and
Yep.
slower.
That's right. That's what's happening. And if you're accelerating, it happens even faster. I'm just doing it for
This is
constant.
what's happening to me on Earth.
Well, I'm just telling you what happened. This is where you have to follow the consequences of these things. And it's crazy, but it's been verified in a gazillion experiments, believe me. So with that, we're going to wrap things up. So here we go. And we'll to be continued next week. I think this has been very instructive in terms of trying to get out in the open. These are really fundamental issues that Ron dealt with, and we want to do justice to them. So we will see you next week. Have a good.
We'll pick up where we're leaving off.
Yep. Bye-bye.